Welcome to Casting Class, the engineer's podcast for all things metal casting. Casting Class is brought to you by Batesville Products, the manufacturing experts who have been casting, machining, and polishing custom aluminum components for over 75 years. Today we're talking about the ugly side of metal casting defects. If you've ever received a casting from your supplier that didn't quite pass the quality check, this one's for you. We're going to talk about several potential defects, how to identify them, and what you and your supplier can do to prevent them. So we can't talk about casting defects without talking about porosity. It's probably the most well-known defect out there, but let's start at the beginning. What's porosity? Gas hole porosity is these small round holes on your part. It's like little bubbles that got trapped inside your casting. The porosity is usually localized to just one area of the casting and isn't found throughout the entire part. So, how does this happen? Gas hole porosity is caused by metal turbulence. Basically, the metal is rushing into your mold at too high of a velocity, sloshing around and trapping air bubbles. If you're experiencing gas hole porosity, you need a better designed pouring and gating system. Dump pours, or when the metal is directly dumped into the mold without a good gating and riser system, can create a lot of turbulence, which creates a lot of porosity. In permanent mold casting, we prefer the tilt pour process. So in the tilt pour process, the mold is mounted to this tilting machine. You pour the metal into a pour cup, and then the machine tilts back at a controlled rate. This lets gravity gradually feed the metal into the cavity at a tilt. So it's gradually running down the sides instead of just splashing into the bottom of the mold. The combination of this tilt pour and the permanent mold gating systems create the least amount of porosity possible. Overall, creating less porosity is all about adjusting your runners, sprues, gating, pouring method, timing, all of that to create less metal turbulence. You want the metal to flow, not tumble into the mold. But why? Why is porosity a problem? Well, a little air in your castings isn't inherently bad. If you're planning on machining, polishing, or powder coating your castings, though, porosity could cause some issues. The holes may mess with machining, polishing, or surface finish specs. And keep in mind, powder coating isn't going to cover up these holes. Instead, it's going to amplify and call attention to all the defects. Porosity is also a problem for industries that need pressure-tight castings or a casting that won't leak. Super porous castings may also absorb its environment. Low porosity is more important for food equipment or medical equipment. For example, you don't want food particles to get trapped in your casting while you're trying to mass produce. Now, this type of gas hole porosity we've been talking about shouldn't be confused with hydrogen gas porosity. Hydrogen gas porosity is a whole different thing. Hydrogen gas porosity also appears as these smooth round holes, but the difference is that it appears throughout the entire casting. It's not localized. It's an internal porosity, so you won't really notice it until you break the surface of the casting. So your part looks fine until you start machining or polishing, and then that starts to mess with critical specs. And because it's throughout the entire casting, it does reduce tensile strength of the part, which can affect performance. Also, you may just visually reject the casting because after polishing, now you see all these tiny little holes on the surface. Instead of metal turbulence, hydrogen gas porosity is actually caused by a reaction between molten aluminum and the hydrogen in the air. We did a whole podcast about the relationship between aluminum and hydrogen if you want to learn more about it. But basically, hydrogen molecules would rather be in the molten aluminum than in the air. So, for example, if you have a hot, humid day, hydrogen's just naturally going to dissolve into the molten metal. You scoop out the metal, pour it into the mold, thinking nothing of it. But when your casting solidifies, all that hydrogen gas is trapped inside and created porosity holes. To prevent this, the foundry has to properly maintain the gas level and temperature of their molten aluminum. There's a process called degassing where you balance out the gas level by adding other additives to the melt. So at Batesville Products, we started using this super cool high-tech automatic degasser. How it works is it has a large spindle that goes down into the molten aluminum. The machine senses the gas level and temperature of the metal, and then it takes into account the temperature and humidity of the atmosphere and takes into account your desired gas level and temperature for the part that you're casting. And then the spindle, it spins around really fast, mixing in all the additives, and those additives combine with hydrogen and bring all the impurities to the surface. So at that point, all your operator has to do is scrape off these impurities and your aluminum's good to go. This really helps prevent hydrogen gas porosity defects. Another defect that might look like porosity is inclusions. So inclusions are holes or a rough surface on a casting. These could be caused by impurities in the metal or even particles stuck in the mold. So for example, you might have heard of sand inclusions before. This means that there are loose sand particles in the mold that create a hole or a rough surface finish on the casting. Sand inclusions are more common in sand casting than they are in permanent mold or die casting, just because you have a lot of sand in sand casting. But if you're using a sand core, you could get an inclusion if a piece breaks off or loose sand sheds into the mold. So we covered the porosity related defects, but what about the others? Other things might be wrong with your casting. You might have cracks, shrink, bends, twists, the list goes on. The good news is that you can avoid a lot of these defects by simply having a good design. If your design is optimized for the manufacturing process, you run less of a risk of shrinkage or even avoid bent castings or short pores. Shrink is more likely to happen if you have a really thick section in comparison to the rest of your part, so prevent shrink by designing gradual changes in your wall thickness, or work with your caster to find a way to send the shrink into the gating instead of into your part. The gating just gets sawed off anyway. For bent castings or misruns, like I mentioned earlier, bending or twisting might mean you don't have enough draft on your casting, so it can't easily eject out of the mold. In permanent mold casting, the exact amount of draft you need really depends on the wall height, but as a general rule of thumb, we'll say about 3 degrees. And then for misruns, these happen when you take the casting out of the mold and part of it's missing. So the metal just didn't completely fill the mold and you have a hole or a gap in the part. This could be a design issue too. For example, if your walls are too thin, the metal is going to solidify before it can completely fill the mold. In permanent mold casting, you're using that gravity tilt pour that we talked about earlier to fill the mold, so we recommend at least a 0.18 inch wall thickness to make sure that the metal fills the entire mold before solidifying. But let's say you listened to our design guide podcast and you designed a great permanent mold casting. You have draft, wall thickness, radii, everything you need to optimize your design for the manufacturing process. But the mold you're using was not optimized. Poorly designed molds and gating systems can cause a lot of issues. For example, even though you have enough draft on your casting, the mold ejector pins could be poorly placed, and that gives you bent or twisted castings. Or the gating system feeds the metal too fast, and that creates a lot of turbulence like we talked about earlier, and that gives you porosity defects. Or even the exact opposite, the gating system feeds the metal way too slow, and it solidifies before it can fill the cavity, so that leaves you with more misruns or short pores. Poorly designed molds could also cause cracked castings. A bad mold design is an expensive mistake, especially for die casting or permanent mold casting. For these casting processes, you're buying a durable steel mold that you expect to be able to use over and over and over again to produce thousands of parts. But you get it and you start running it and you can't get one good part off of it. Once that mold is built, you can tweak it, but it's hard to make any major changes to it. Plus, you already paid for a mold that was supposed to last you years and make thousands of parts, and now you have to pay to fix it. This is why it's so important to work with a supplier that you can trust, one with a good track record of producing high-quality castings. When designing a mold, a good supplier might use a tool called a finite element analysis. So this is just part of a casting simulation. The simulation lets you take that mold design and predict how the metal will flow into it. So you can see if there are any places where the metal doesn't completely fill, or places with excessive turbulence that might lead to porosity defects. The simulation also shows the solidification process and temperature, so you can see any hot spots that might turn into shrink defects. If you see any of these potential defects, you can adjust your design, run the simulation again, and make sure that you're designing them all out. We run this simulation for every project we take on. I mean, why take the risk of building a new tool without it? We can build a better mold that lasts longer and makes better castings. We've also found through decades of casting that building a good mold from the start is essential, but you also have to maintain it. To make a permanent mold last a long time like it's supposed to, you have to take care of it in between runs. Make sure the aluminum isn't fusing onto it, coating the molds, cleaning the molds. If your castings are getting a rougher surface finish than the process should be able to maintain, this could be a sign of mold wear. One defect we haven't really talked about yet is flash. So flash is when you get these thin little sheets of metal sticking off of your casting. It's caused by metal leaking out of the mold during the pouring process. A little flash is manageable, you can just machine or polish it off, but excessive flash is a telltale sign that your mold is reaching the end of its lifespan. Some other defects that could be caused by poor mold maintenance are rough surface finish, like we talked about earlier, parting line shift, mold misalignment, or even inclusions. Now there's one last thing to consider when it comes to casting defects. You can have a perfectly designed casting, a perfect mold, and still get defects if the foundry making your casting isn't following the best practices. There's more to metal casting than just dumping metal into a mold. You're balancing gases, temperature of the metal, temperature of the mold, pouring techniques, and more. So my final piece of advice, the best way to avoid casting defects is to choose an experienced supplier from the start. Get out and visit suppliers in person. Do they have a quality procedure in place? Are they ISO certified? Do they take preventable measures like maintaining the molds or monitoring gas level and temperature? What happens if they do produce a bad part? What's their policies like? Now, you aren't guaranteed to cast a perfect product every single pour. Everyone has scrap once in a while. It's not ideal, but it does happen. But it's all about finding a foundry that when scrap does happen, they have the experience and the knowledge to take corrective action and get your product line back on track. If you really want to avoid casting defects, look for a supplier with preventative measures in place and the reputation to consistently deliver high-quality product. Thanks for listening to Casting Class, the engineer's podcast for all things metal casting. For more episodes, videos, and guides, check out BatesvilleProducts.com. See you next month!